Now that we've gained some experience putting together an app that uses the user's location together with annotations of places that might be important to you, I want to show you some enhancements that we can add to make this an even more powerful app. So you can see that this in the simulator is now reporting my location to be at the school. And so let's play around with this a little bit. This function here is the function that runs when locations have been updated in the map. So when the location of the phone has changed or has been updated, it runs this function. And so what this has done, what this line does, is it sets this variable current location, which we've created in our app, and which stores a location on the map. When the location of the phone is updated, we store the location of the phone in this variable called current location. If we want to instead center the map at that location whenever the phone's location has changed, then we can use something that we've learned in our previous map view work in order to recenter that map. So here's what we do. We can start typing map view, and we can do the center coordinate. And what we'd like to do is actually set the center coordinate of our map to be the coordinate of our current location. If you just put current location, it's going to complain because the center coordinate of the map is this thing called CL location coordinate 2D, and the location as reported by the phone is this data type called the CLL location. In order to get the coordinate of the location, we can put quarter. So if I set the center of the map to be this coordinate, I still get this little error, and that is because current location might not have a value. That's what this question mark means. So I'm actually going to replace that question mark with an exclamation point. When I now run this in the simulator, everything looks pretty normal, but let's try changing the location a little bit. Maybe 7318. Okay, so now that my location has shifted, it moves the user location a little bit further away. Let's really try making a drastic change to this app now. So this is a view of Tufts University. That's where I went to school, and I've actually gotten the coordinates of the center of campus, which is 42.407422, and so on. It's right here. So let's copy this coordinate, and let's paste it in as the simulated location of the phone. Make sure you get that negative sign in there because this tells us whether we are west or east of 0 longitude. So when I hit OK, it zooms us around the world to Tufts University. Now the reason I wanted to show you this is that I know that Austin, in some of his locations, put some points on the map that are in Boston. So these are actually Austin's locations from our list of locations in this app. And so by changing the location to Boston, we can now see Austin's locations on the screen. All right, let's add another feature. Let's make it so that not only can we see a map view, but we can see a label that tells us which of the locations in our list is closest. So we're going to have to reconfigure the screen of our app to make that work. The first thing we need to do is delete these constraints. These were the settings that I included originally to say stretch the map view so that it was 10 pixels from the top, 10 pixels from the right, 10 from the bottom, 10 from the left. So it made it so that that map would fill the entire thing. Let's delete those constraints now. Next thing is I want to combine this map view with a label where I can show a message about the nearest location. Now putting these inside of a stack view means that I can keep these two things together, and I know that with a stack view, it's going to keep the location of the different elements, the map and my label, and it's going to treat those as one unit. And so now what I can do is I can set the location of this stack view, and give it the same constraints as what I had with the map view before, so that it stretches those two things to fill the entire screen. Okay, so let's select our stack view. Let's change this to fill equally. And you can see these now have the same width. And let's run this in the simulator. All right, so we can see we have our map taking up half the space, and then our label. So let's go to the next step, and let's try to make it so that this label updates with the location that is closest to where the user is actually located. The first thing we have to do in order to make that happen is we actually have to add this label to the code, because right now they are not connected to each other. So we're going to go to our label, and we're going to do control drag in and give it a name of location label. So that's the first thing. Second thing we want to do is we want to make it so that when our app first runs, we want to put in some text that says the nearest location is currently unknown, because it might take a little bit of time after our app loads to actually get the location of the phone and load it into the app. It doesn't immediately know where it is, so that could take some time. The next thing that we'd like it to do is to identify, let's create a variable, let's call it nearest location. This is going to be a map location. And we're putting the question mark in because when our app first loads, our phone may not have identified the nearest location. And so we want to tell Swift that that's okay. We're creating some space for the phone to store that information. We're just not yet giving that location necessarily when this first loads. So let's try that real quick and make sure that it works. Okay, so there's our location and our text is updated, so we're in good shape. Next thing we want to do is we would like, inside this location manager, to do this if So what this code does is that if there is a nearest location, if it has a value, then let's update the text inside this label to say what the title of the nearest location is. So this in our map corresponds with things like the alley or Starbucks panorama. So it tells us which location is closest. But it will only run this if this is possible. If it's not, then it won't run this. Now the question is, how do we find the nearest location to where the user's phone is? It turns out that we have actually done this code already. We used a function that did this in a previous activity. So this function right here will identify the closest location. It will return a map location, and it will do this using the location array. So let's take this and paste it right below this function. This function takes a location, it takes an array of locations, and it returns the map location that is the closest to it. So what we now want to put in is some code that will make it so that the nearest location is equal to whatever this function finds as the nearest location. So we're going to run this function, and the input location is going to be the current location of the phone. So we're going to do that. I'm going to hit the exclamation point because we know there's going to be a location at this point. And the location array that I want to use is this list of locations, this our location list that we've been using all along. So nearest location will give us, will find the closest location based on what the phone is telling us is our current location, and our location array is this list of places that I've loaded in from the class. Let's try this out. Okay, so you can see that the nearest location right now is SSIS, which makes sense. Let's try adjusting this a little bit. So now when I adjust the location and it moves me up here, maybe on the northern side of Winban Lin, you can see that now this place is the closest location. So it seems to be working. Now let's try putting in the coordinates for Tufts and see if Austin's locations pop up. So we're whisked away to Tufts University. You can see, sure enough, that the nearest location is Fenway Park, which, if we move across the Charles River, sure enough, that is the nearest one. So this is working exactly as we expect it to.